So welcome back, students. Today we're going to continue working with the revolve command as well as extrude. So we'll be working with both of those today. We're going to create three different type of popular cap screws. One of them is a countersink screw. One of them is a socket head cap screw. And one of them is a hex cap screw. We're going to create those in Inventor, but I just want to make you aware you don't necessarily have to go and reinvent the wheel. A lot of times you can find these screws online at various places. They're already modeled. You don't have to create them. In the next video, I will show you how to go to a distributor like McMaster-Carr and look up the screw sizes and basically just import the screw that you need. All right, so here we go. Without further ado, I'm going to share my screen. And when you do, your screen will look like this. Now there is a table of dimensions for each type of screw that's in the module. I have given the face-to-face students a hard copy. And for those students who are taking the class online, you will find the chart in the module. It's OER13, okay? So what we want to do first is we want to go to New. Again, we want to, we're going to be creating English threads today, so go ahead and select English. And select Standard IPT. And come down here and select Create. And your screen should look like this, okay? So go ahead and select Start 2D Sketch. Start 2D Sketch. And we're going to click on the frontal plane, which is the XY plane. So click on this plane. All right. And as before, you can always zoom in by rotating your scroll wheel. You can hold the scroll wheel down to pan. All right. So I want to use the revolve command to make some screws today. And the first one we're going to do, if you look at the handout that I gave you, and this handout is, again, you can access this handout in the OER13 module. If you look on page 1, there's two charts on page 1. There's one for a flathead screw or a countersink screw, and there's one for a socket head cap screw. Well, we're gonna do the socket head cap screw, and you can see there's a little drawing there with some dimensions. You have to look on the table to find the right dimensions. All right. So, for example, today we're going to create a 1/2-inch screw with 13 threads per inch. Now, Mr. Morris's eyes are not that great, but I see a 1/2 inch. And I don't see, I know 13 is the right number of threads. So as a coarse thread. All right. But it doesn't tell us the number of threads there, but I'll show you how to do that on the drawing. Or when we're actually making the model. All right, so here we go. So, and we're going to make all these about I'm going to say we're going to make all of them about 1 inch long. Okay. Make all these screws about 1 inch long. So let's get started. All right. So this is your origin right here. This is your origin. Now the screw diameter is 1/2 inch. So what we want to do is take half of that. So go to line and then select line and move your cursor near the origin. We're going to click and we're going to drag a line straight up, and we're going to make this 1/2 of 1/2, right? So that's going to be 0.250. 1/4 inch is 1/2 of 1/2, right? All right, you can zoom in out with your scroll wheel and you can pan. Now I'm going to go this way. And I said I was going to make the screw 1 inch long. So I'm typing 1 here. All right, now I gotta make the head of the screw. So I'm looking at this drawing here, or this table of, and it says the head diameter for a 1/2 inch screw. What is it for the socket head cap screw? Can someone tell me what the head diameter is for a 1/2 inch screw? What is the diameter of the head? It's under A. They gave you the max and the min. Give me the max. It's point what? 750. You see that? Okay. So I've already gone up. I've already gone up 1/4 of an inch. I got to do half. So if I've gone up 1/4 of an inch, I've got to go up another 1/8 of an inch to get half of the diameter of the head of the screw. So we're going to add 1/8 of an inch here. Then I'm going to turn to the right. Turn to the right. Now I need to know the thickness of the head, which is H. Can someone go down that same place and tell me what H is? It's 0.5, right? 0.5. Now watch carefully. I'm going to come back down. I'm going to come back down to where I'm touching the x-axis. And I'm going to click. And then I'm going to come over here to the origin. And I'm going to click here. Click. And right click. Okay. So this is what I want you to, this is what I wanted you to create right here. So I'll give you a second. I'll give you some dimensions here just in case you need them. The reason why it puts the parentheses around this dimension, because this is a reference dimension, we have this dimension and this dimension that defines this one. So that's why they put the parentheses around. Okay. So everybody got this? All right, we're going to go up here and we're going to select the green check mark. Now, what it wants us to do is it wants us to revolve this profile. So select revolve. And then we want to, right here where it says axis, it already picked up the profile. This is step 1. It picked up the profile. See how it painted it blue? Now we want to select the axis. Select this line right here. You're going to have to click on that arrow right there and select OK. Now you can go up here to your view cube and you can look at the screw we've created so far. We're not done with this, obviously. All right. So now what we need to do is we need to add what our chamfers are, okay? Now, that is dimension C. From what I can tell, that is dimension C on this drawing. So if you go down, what is the chamfer distance for a half 13? Gotta talk louder. 0.055. So go to chamfer, and for distance, put 0.055. And we're going to click here on this edge, and we're going to click here on this edge. Now, select OK. Now, since you students are in the machining program, my face-to-face students are in the machining program here at Virginia Peninsula Community College, why don't you give me a guess as to why we need chamfer? Why we need a chamfer on this edge and on this edge? Anyone want to take a guess as to why we might need a chamfer here and a chamfer here? Well, this chamfer here on the head of the screw removes all the sharp burrs. When you make something, machine something, a lot of times you have sharp edges or burrs that you want to remove, okay? So that's why we have a chamfer here. We have a chamfer right here, okay? We have a chamfer here so that it can center into the hole. In other words, it's going to screw into it. It's going to screw into a hole that's threaded or nut. And that chamfer helps to center the screw. So it makes it easier to screw into a nut or to a threaded hole. One more time. This chamfer right here is there so that it can screw into a hole much easier. If you don't put a chamfer there, it's going to be much harder to start that thread. It's going to be much harder to start that first thread. So you put a chamfer there, it makes it much easier, okay? Now that we have the general shape of the screw, on your menu bar at the top, there's an icon called thread. There's an icon called thread. Please select thread. And you want to just kind of come down here and touch off. If you touch off on the side of this, just touch off on it. Look over here in the window, the dialog box that came down. It says what? 1/2 13 UNC. 1/2 is the diameter, 13 threads per inch. Unified National Course thread. There's the decimal equivalent, 0.5. And the threads are the full depth of the part. So I'm going to select OK. All right, now we have threads. Okay, now we have threads. Now we need to come over here because we have to create, these are socket head cap screws, and you have to use Allen wrenches. You have to use Allen wrenches to remove or to tighten these screws, right? So we're going to go to Start 2D Sketch, Start 2D Sketch, and we're going to click on this face right here. All right. Now, if you go look at the table, we're still working on the same line. We need dimension J now. What is dimension J? Is what we need. So we take our 3/8. Very good. So what I'm going to do is I'm going to draw me a construction circle first. So go to circle, go to center, circle center point, and click on the center right here. And we're going to drag out a circle 0.375. Right click, okay. Now, this circle just serves as a reference for me because I'm getting ready to create a hex because it's a socket head cap screw and it has to be a hex. So come over here to where it says rectangle and arrow down. Go down to where it says polygon. And we want 6 sides because the hexagon has 6 sides. So bring your cursor over to the center. It will turn green. Click, and I want you to drag out a circle, or excuse me. Actually, I think I want to do this. I tell you what, I'm not quite sure I want to do it that way. Let me just check something first. Hang on. 6. Yeah, that's what I wanted to do. Sorry. I'm gonna undo this. Watch. Okay. So I just did undo, right? I'm going to go to polygon. I want 6, but look, don't select this one. Select this one, circumscribed. Okay. And we're going to come over here and we're going to click at the center and we're going to got to make sure you click on that one. This one right here. See this one? There's 2 of them. Click on this one. And we're going to go up at the 12 o'clock position and it's going to snap right there. Click. Do a right click. Okay. Now we don't need this circle anymore. There was a construction circle. So we can do a right click and delete that. I don't need that. Now, what is the depth of the socket? Look at the drawing. It says T. That's how much engagement that your Allen wrench is going to have with the socket head. And I'm glad someone has better eyes than Mr. Morris. 0.245 is correct. So go to finish the sketch, and we're going to go to extrude. We don't want to go this direction. We want to go in, but before we go in, we put 0.245, and we want to go flip the direction right there. Select OK. All right. Now, so we make this look more like a screw. We're going to, hopefully everybody has this. We're going to go over here to, we're going to save it. File, save as. And I'm going to put socket, bless you, socket head cap screw. Socket head cap screw. Actually, if you don't enter that yet, you could abbreviate this. You can abbreviate head with HD. Okay. So socket head cap screw. Save. All right, now we want to change the material of this. We want to change the material of this. Come over here to the browser, right? We do a right click, come down to iProperties, and we're going to go to physical, and we're going to arrow down with the material. And I always like to use Steel alloy, I always think that looks pretty cool. Fly, close. Now it looks like a metal screw. Nice and shiny. Okay. Now, like I was saying earlier, you don't have to create these screws because there are a lot of apps and a lot of like McMaster car, you can go and find this exact screw and download it. You don't have to recreate the wheel here. But I just want to show you, yes, you can create your own. Sometimes you have a special screw. By the way, it's made on, it would be made on a lathe. The majority of this would be, but you're not going to make these. You would buy the screw. Really, it's the standard part. So you're not going to be you're not going to be making screws in the machine shop unless it's a special type screw. Okay. So file, save this. So that socket head cap screw. Now we're going to do on page, same page, page 1. Okay, page 1. At the very top is a countersink type of screw, right? And we're going to keep it the same size. So we'll use a 1/2 13 as our thread designation. And then all of our other dimensions will be there that we need to model the screw, right? So we're going to leave this here, go to File, New, English, Standard IPT, Create. Start 2D sketch, start 2D sketch. All right, now we're going to click on the XY plane. Okay. And we are going, again, we're going to do a revolve. We're going to do a revolve here. So, go to line, go to the center, it's going to snap, click, and we're going to go up half the diameter. Well, if it's 1/2 inch, we're going to go 0.25 again. Now this time I want to be a little bit different in the length. We did 1 inch last time. Let's be a little different. Let's make it 1.5 here. Okay, that's the length of the screw. And then I want you to draw a line at an arbitrary, just draw an arbitrary line going up at a slight angle like this, okay? Just at a slight angle, just like this, and click, do a right click, okay. Now, what we have to do here is the angle between this side and the other side of the screw that it's not shown here, is roughly 82 degrees. All right, it's 82 degrees. So what we have to do, watch carefully, is we have to come in here and we have to put a dimension like here. And the reason why it won't do this here is because I don't have a line, a horizontal construction line. So I'm gonna hit the escape. I'm gonna go to line, and draw a line along the x-axis. You notice I didn't care about the length of it yet. And all I really wanted to do was, I was pretty close, wasn't I? Really, that's amazing. I want that to be 41 degrees, half. Okay, so it didn't change very much for me, did it? Now, what is the thickness of the head of the screw? What is the thickness? Do you see the thickness dimension for the head of the screw? for 1/2 13. It's very odd here because that must be in millimeters. I don't know why they would mix millimeters with inches. Okay. So we have to do a calculation here. Let me hang on just 1 second. Sorry about this. This should be straightforward. The S dimension is right. We can't create the S dimension yet though. But we need to know K. And we know K is, it looks like it's 6.375 millimeters. So we have to convert that. Okay. So we're going to take 6.375 divided by 25.4. And it's basically 1/4 of an inch. I don't know why they didn't just leave all the dimensions in English units, but they didn't. So that dimension K, the thickness of the head should be 1/4. All right, so here you go. Mr. Morris, how am I going to do that? You're going to draw a construction line. Going to draw a construction line right here. Look, going to snap. Going to come down, click. This is a construction line only, and I want to offset that line. Go to offset, click on this line and come this way, 0.25 inches. Do a right click, okay. All right, now we don't need this line here anymore. You can do a right click on that and delete it. You don't need it. And we need to do some extends and I made a new word, extremes. Let's do extend here. Here's the extend button right here. Click on that. Click on that. All right, so I extended that line up to this line here. Do a right click, okay. So I want to trim now. Trim this, this, and this. Right click, okay. So I'm ready to revolve this. I'm going to finish. And I'm going to go to revolve. Notice it picks up that closed profile there. And I'm going to select the axis, which is there. Select OK. Now what I'm going to do is I'm going to do the same thing I did before. I'm going to look on here and see if they might not have a chamfer size. If they don't, we'll just use what we used before. I don't see where they indicate the chamfer size. So we'll make it the same as what we saw before. Let's see. Have it was C 0.055. So go to chamfer, and click on this edge right here. And we're going to make it 0.055 and apply. All right, now we're not going to do that up here. We're not going to do that on this edge. We're not going to put a chamfer on this edge here. Because remember, when it comes down, you want it to be flush with your surface of your whatever. It could be a machine part. You might want it to be flush with the floor. All right, so now, Mr. Morris, what can we do next? Well, we can come over here to where it says thread. See where it says thread? And we can come down here and click on that surface. See, it says what? It automatically knows that is one of these values right here. And we're not going to go over all these today, but that's a half inch is the diameter, 13 threads per inch, unified national course. Okay. It's a class 2A fit. Actually, it's a fit class. Fit classification is 2. And the A means external threads. If you see a B here, that means internal threads. Okay. So that looks good. Select OK. Now, you're doing good with the screws. Now we're going to start 2D sketch, and click on this face. It's hard to see, but the S dimension for half 13 is 5/16. Go in here and draw a circle. And we could actually type in a fraction, 5 divided by 16. Right-click OK, go to Polygon, right here. And we want it to be 6 sides. We're going to click on this one, circumscribed. And we're going to come in here in the middle of the circle and click. I'm going to undo that because I don't know why that yellow circle's there. I'm going to go to Polygon, click here, make sure you click the second one because it automatically defaults to the first one right here. We don't want that. We want this one. Right click OK. Let's delete this circle here. We don't need that. Okay. Now we're going to finish the sketch. And if you look at this, it goes down a depth of little t. Let's have, yeah, the minimum. All right. So for that screw size, it's 4.36. So we're going to take 4.369. 4.369 and divide it by 25.4, and it's 0.172 is the depth. So we're going to extrude, and we're going to go down. We're going to go the opposite way, but we're only going to go down 0.172. And you can see how far it goes, right? If you turn it to the side here. Select OK. All right, very good. Now we're going to come over here. We're going to file, and we're going to save as flat head screw. Flat head screw. The actual correct name for this is a countersink screw, but we'll just call it a flathead screw. It's actually a flathead socket head screw. It's got a socket to receive an Allen wrench. Select save. Why do you think machinists need to know about screws? Do they need to know about screws? Absolutely they do, especially outside machinists. They have to assemble stuff all the time. So I'm going to do a right click here on this file name, go to iProperties, physical, and we're going to go down to steel alloy and apply, close. That's not as shiny. Yeah, it's kind of shiny there. Did y'all get that? All right. So we have 2 screws. We got one more screw to make. Okay, we got one more screw to make. And we're going to make the second page. Hex head cap screws. Half inch. We really just need the head, the the size for the head of the screw, because the rest of it's pretty easy. Start 2D sketch. Start 2D sketch. Oops, sorry. What did I do wrong? Got to start a new file. File new. English. Don't y'all let Mr. Morse get away with that kind of stuff. English. Standard IPT. Create. Start 2D sketch. Start 2D sketch. Click on this XY plane. And this time, I'm going to do this a little bit different. I'm going to draw a circle at the center, and I'll make it 0.5. Do a right click, OK. I'm going to get into the isometric view. I'm going to zoom out with the scroll wheel. I'm going to finish the sketch. I'm going to select extrude. I don't want to go this way. I want to go the other way. And I'm going to make it one. Let's say we made one 1 inch. We made the other one 1.5. We'll make this one 1.75. Those are standard dimensions. Select OK. All right. Now we need to put a hex head on this. Start 2D sketch, start 2D sketch, click on this face right here. We're going to come here, we're going to draw a construction circle. And it says the head of our screw across the flats. The head of our screw across the flats is A. The head of our screw across the corners is B. You see that at the top of the drawing? You have an A dimension, you have a B dimension. They're not the same because one is referenced across the flats and the other dimension is across the corners. So we're going to use size A, and for half 13, it looks like it's 3/4. So we're going to type in 0.75, enter. Do a right click, OK. All right, now we want to go to polygon, it was 6 sides. We're going to click. Now we want to use this second one here, circumscribed. Click here, and you're going to come out. It's going to snap to the 12 o'clock position. Click, right click, OK. Now we're going to delete this circle here. Delete. All right. I'm going to finish this. What is the height of our head? Is H. I'm not going to show all the fine details of this. I'm going to show some of them. Excuse me. So we're going to make it just a second. H. Mr. Morris can't see this. I think it's 5/16. Do y'all agree with that? Or actually, yeah, it's 5/16. So look here, go to extrude. And we're going to type, you can type in a fraction, 5 divided by 16. Select OK, or enter. How big did you make the hex? Well, I drew a construction circle that was 3/4, 0.75. And then I did the hex so that, look, I can undo it. I drew a circle, look here. That was 3/4, 0.750, right? And then I went to look, polygon, 6 sides. I clicked here, but you got to check, you got to click on this one here, not this one, but this one. And you move it to the 12 o'clock position, right click, OK. I deleted the circle. I didn't need the circle no more. And I finished the sketch and extrude And I made this, I just typed in the fraction 5 divided by 16. I said, okay. Did you get it? There's some other little details about this, but I'm not going to spend a whole lot of time doing that because here's why. For the most part, you're going to be downloading. I'm going to show you how to do that. I'm going to do that in a different video, though. I'm going to do that in a different video. So now we need to add the threads to this. We need to add the threads to this. So that's okay. All right, we got that. We want to add a chamfer to this. The chamfer, I'm going to leave it the same as all the others, 0.055. We'll click here. Select apply, and then close it out. Now, what we're going to do next is we're going to add a material. Well, we should probably save it first. File, save as, and we're going to call it hex head screw. Hex head screw, save. Now we're going to give them designate a material, come over to the browser, do a right click on the file name, come down to iProperties. We're going to go to physical, and we're going to arrow down under material. And if you want to be different, you can. I've just been using steel alloy, but there's other materials that screws are made out of. Brass, there's some brass ones. I don't like that one too much, but that's okay. That's a brass screw. All right, I'm gonna file save this. Mr. Morris, I have 3 IPT files here. Make sure you save them somewhere where you can access them, okay? Also, go back to your first one. Go back to your first one. This one here we created. Get a file, export, image, and we're going to make, some people are not selecting PNG. All the others don't have the same quality. So make sure you select PNG, save. Okay, now we'll get a picture of this. Go to this one. I don't know why this looks kind of blah, but it's got that luster to it, so that is correct. File, we're going to go to file, export, image. I don't know why the file name didn't come up on it. Let me cancel that for a minute. This is the file name that's pulled up. So file, export, image. All right, well, I'll just rename it. It's really strange. Flathead screw. I'm gonna put it in my documents. I'll be able to find it later. Save. Add one more, this hex head screw. Okay. You can do that. I actually think you see more details from this one, from this side. So I'm gonna file, right, export. It's doing it again. And this is hex head screw. I think the last one I did should have been socket. No, I did it right. See? So those are three PNG files you have to submit, three of them. Now we have to make our drawing. All right. We go to File, New, English, Standardized. No, not this one. I'm sorry. Select English and come down here. I'm so used to selecting IPT. Select American National Standards Institute, Inventor drawing file and inches. Click on this, create. I don't want this size sheet of paper. Come over here to the browser, do a right click on sheet 1 and edit the sheet. And we want to make it a size A, and it's okay to leave it landscape. Okay. So we're going to get a base. The first one that came in is the last screw that we did. Now, if you want to pull in the first screw that we did, come over here. Look, this is important. There's a little file folder right here. And we need to find the first one we did, or I do, which was this one. And I'm going to select the open. All right, I'm not going to change. I'm just going to say okay. And I'm going to move this about right here. Let's say, and then I'm going to project. Look, project, click, click. Come back over here and we're going to do this. Look. All right, so that screw is in there. We might have to change the scale of this a little bit later. Now, let's come over here, go to base. We're going to bring in multiple parts this time and go to the little file. And the one we just brought in is, let's bring in this one. Open. And say, okay, look. And we're going to project. Now, if you want to go back and shade these, you can just hover till you see the red rectangle appear around that view. And we're going to do a right click in here and we're going to edit the view and we want to shade it. Okay. And right here on this one, so it shows the thread. By the way, the threads are a picture. I'm going to right click in that box, edit the view, shade it. Say okay. All right. Now, I got to get clever here because I got one more to bring in. So this is where you have to use your skills, layout skills. I'm going to go to base. And this time I want the hex head. And we're going to select okay. Actually, I want to undo that because I want to go to base. Yeah. I don't want that view. Here's my view cube right here. I want that view. Select okay. So I'm going to start kind of moving things, shifting things around here a little bit so I can create some more room. Projected. If you projected, click, you see the red box appear, click, come over here, drag the side view, come up here and do this. All right, so we got to work out some spacing issues here, but I think we should be able to get it to fit. But you want your drawing to be neat. You want it to be laid out uniformly, right? Well, let's see. I think I'm just trying to squeeze too much on one page, but that's okay. We'll make it work. All right. You see how I was trying to keep the head of the bolts lined up. In other words, this one lined up with this one, and so it looks somewhat uniform. I'm not going to label the views this time. I'm just going to put a note as to what size they are. All right, now what we need to do now is this. We need to just put in some overall dimensions here, but before we do that, we have to go to annotate, and we're going to put in center marks. I'll put in a center mark here. Look, see that? One here and one there. Actually, we don't need one on the last one. We don't need one because those are hidden lines. That's just showing you the threads. Okay, now we need to put another center line. Go to the bisector right here, the bisector. We're going to click here and here and here and here and here and here. Right click, cancel. All right. Now, whatever method I use to dimension these, I need to be consistent. So really, I'm just going to dimension, well, if you go right here where it says hole and thread, I love this feature. If you click on hole and thread and come here and click on this edge, look, it tells you exactly what that size should be. Now you can move these arrows a little bit more if you go off the page. You can always hold down your left mouse button and drag that. Do I need to show you that again? One more time. Look. You go to hole and thread, click on the thread itself, and you can drag it out. Click. Right click, okay. So I like that one. I'm going to be consistent now. So if I did that here, I'm going to do it over here. So I'm going to go to hole and thread, click. See that? See how nice that is. Right click, okay. And then I'm going to use one more. Now we can shift these around as needed. Okay. I want to see how neat you actually lay out your drawing. Now we need to put some dimensions. So go to dimension tool, and I'm going to dimension from this point here to here, if it lets me do it. And that's absolutely beautiful. I'm gonna leave it like that. The diameter or the head, look, we can do this to show the height of the head. So we have the length of the threads here. I'm not going to put the chamfer dimension on here because again, these are standard parts anyway. But you do need this dimension, you need this dimension, you need this one, so you can design your counterbores for this to go into. I'm going to click here. This is the size of the head, the diameter. And if you want to give a dimension across the flats, here's how you would do it. Look, you can click on this flat, and bring a dimension out like this. Now, I don't like how that dimension is so close to that, so I can hold down my left mouse button and move it over to here. That tells me what size Allen wrench I would need. It tells me the size. I know the head is a 1/2 inch tall, a 3/4 diameter. One other dimension you could put if you want is this one here. That one. So I think that one's done. Right click, okay. And again, the challenge mainly is just trying to get it to fit all on one sheet. I'm going to repeat that for the other ones. I'm going to come in here and I'm going to put this dimension here. I'm going to put the height of the head right here. Select OK. We don't need a diameter here, but it would be nice to have dimensions across the flats. By the way, if you say dimensions across the corners, you do this, but we're not doing that. We're doing dimension across the flats. So we can do this one and this one. Okay. And I know I'm getting kind of close here, so I'm gonna bump this up a little bit. So we got the thread size, we have the length of the thread, we have the overall length of the bolt here. We have the overall length. If you take these two numbers and add them up, you have the overall length of the bolt here. We're gonna do the same thing now for this one. Look, we're gonna dimension here. And we're gonna put this dimension here. We got some breathing room on this side, right? We're going to dimension this. How is that? Oh, I know why. Angle. If you want to put the depth of the sets, we could put a dimension across the flats here. Now, see how that's kind of going into the angle. I can always move the angle in some. Okay, I'm gonna hold down my left mouse button, move it down some. I was gonna put this depth in there, from here to here. Is that what that was? 0.17? Let's see here. Yeah, because we took 4.369. 4.36. Hang on. Let me check my calculator. Yep, that's correct. That's right. Now, if you want, you could do this. You could do this if you want. You can spread this out some more and you can, where this fills up the hole. But Does yours look like this? Now we have to do our, I didn't put the labels because we kind of ran out of room. But what we can do, normally you put the labels under the view labels. But we can, if you want, we can do this. You go to text and click right here. And we're going to say socket, head, cap screw. And you can make it bold and underline it. Select OK. Now you can move this like over here up in this corner. That's what that one is. And we can do a right click, copy, come in here and do a right click and paste. We can place that right there. And we can double click on that. And we can call that, what is that one again? That's the hex head cap screw. By the way, I got a PowerPoint that I'm going to go with you next time I meet with you all in this class. It won't be no drawing that particular day. We'll be going over a PowerPoint, and I'll be introducing you to a lot of different types of screws and fasteners. Okay. You are the artist here trying to make this work so it looks nice, nicely laid out. Now I'm going to come here and do this again, right here, perhaps. And this is going to be a flat head cap screw. Highlight this, make it bold on the lines. That's okay. Right click OK. All right. Now we need to fill out our title block. So come over here to the browser, right click on this, go to iProperties, summary. The title of this is variety of cap screws. Okay. Subject is CAD 140. The author is you. The manager is me. And the company is Virginia Peninsula Community College. Okay. Get a project. You are the designer. You are the engineer. Mr. Morris is the authority. And go to status, checked by you. Click on the date. Engineer approved by you. Click on the date. Manufacturer approved by me. On the date. Apply. Close. We'll do a file. Save as variety of cap screws. Save. What do you think, May? Does that look all right? All right, so I'm going to remember, save all your IPT files, save all your IDW files, save all your PNG files, which are your picture files. And we're going to save this as a PDF. Go to File, Export, PDF, save. Okie dokie. We are done. So the next time I'm going to give you the rest of the day to work on stuff. you have only about 30 minutes or so. And the next time we meet in this class, I will go over a very detailed, I wouldn't miss this very important lecture. I won't be going over a drawing that day, perhaps, but at any rate, it's important to know these different types of screws. Because when you're out in the field working, you don't want to say, I don't know. When someone tells you, hey, May, can you go to Tool Crib and get us some 1/4-20 socket head cap screws? And she's like, what? I want May to say, sure, I know exactly what you want. I'll be back in a second. All right, we have to save this as a PDF one more time. File, export, PDF, save. Yes. This is what you're going to need to put in the, I got to create a assignment yet for this. So give me a chance to do that. I have to move these over to the proper module also. So I'm going to stop the share here and say goodbye until next time, my online students. Take care. Let me stop, get the recording, stop it.